All right, everyone can see?
Yes.
Okay, fantastic. Good, good, good. Okay, so let's go through uh, some of the questions here. Why is this not working? Ah, there we go. Okay, so some of you did finish the slope stuff here. Some of you did not. So let's kind of go over and take up the answers here. So the slope equation, once again, it was question B. So m is equal to y2 minus y1 over x2 minus x1. Y2 being 3, y1 being -5, x2 being 7, and x1 being 5. So this is how you should have plugged it in. I asked you to do this yesterday during those 15 minutes to try to solve it on your own. What you should have gotten is 8 over 2, which gives you 4 over 1, or just 4. That was the first one here. A lot of answers that I was getting DM'd on Zoom was like people mixing up the numbers, right? So you got to be careful. So once again, indicate, oh, this is 0.1, this is 0.2, x1 is 3, y1 is 9, x2 is 1, y2 is 8. Like it's tedious. It takes a longer period of time, but at least you're not getting it wrong when you plug it into the formula. So when we plug it in correctly, we get 8 minus 9, and 1 minus 3. This will give us -1 over -2. Two negatives make a positive, so it's just +1 over 2. So this is kind of the idea, right? You want to list it out and then solve into the formula. I'm going to do question F as our last one here. So once again, 0.1, 0.2, as listed, x1 is 0, y1 is -2, x2 is -6, y2 is 4. Plugging it into my formula, 4 minus -2, and then -6 minus 0. And subtracting that, 4 minus -2 is +6. -6 minus 0 is -6. 6 divided by -6 will give you -1. And that's your final answer there. Okay? So you got to make sure, right? Plugging it in correctly, like the formula is given to you, so it would suck for you to get it wrong just because you mixed up a number here or there, right? So you really don't want to mix that up and mess that up, right? So the main idea here is making sure you know what x1 is, you know what x2 is, you know what y1 is, you know what y2 is, and correctly placing it into the formula. So let's keep going here, right? Slope as a rate of change. So this is where we left off yesterday. So I've already mentioned, right? Slope is the same thing as rate of change. It's just that rate of change is what we use when we talk about like actual relationships between comparing different quantities. So essentially, like word problems. When we're looking at a situation, we usually use rate of change as what we're talking about here. So it's a change in one quantity relative to another. So whether that's dollars per hour or meters per second, kilometers per hour, right? It could be a whole bunch of stuff. That's going to be your rate of change. So now, it requires units. It's not a decimal, but it's what it means by it's a decimal is a fraction, right? You're dividing stuff. So let's change that. And it's a fraction, not a decimal fraction. That should be fixed. And so rate of change, just like on distance time graphs, the rate of change would be the speed of a distance time graph and can be found using the slope because it's the same thing. So rise over run, and it has to include the units. So the change in one quantity over the change in another. And it's always y over x because it's rise over run, right? Rise is vertical, that's the y, and run is horizontal, that's the x. So when we look at a situation like this, right? it says here, the following graph shows the volume of gas remaining in a car's tank. The gas in the tank is in the y-axis. The distance traveled is in the x-axis here. So it asks us to calculate the slope of the graph. You can do this in different ways, whether you want to use the rise over run or you can use the formula. Let's use the formula for this one, just so that we can get used to it. So I'm going to copy down the formula here. M is equal to y2 minus y1 over x2 minus x1. Okay. We have our 2 points. The 2 points are 0, 65, and 500, and then 5. Okay. So when we plug it into our formula, we need to first figure out what's x1, y1, x2, y2. So here x1 is 0, y1 is 65, x2 is 500, and y2 is 5. So we have our values here. We're going to plug it into our formula. So we said y2 is 5, y1 is 65, x2 is 500, and x1 is 0. Plugging that in, we get negative 60 over 500. And can we divide that? Yes, we can. We're going to get a decimal here. We're going to get negative 0.12. If you wanted to keep it as a fraction, you can reduce it twice, and you should get negative 3 over 25. That's your other way of writing it. I should write it beside it, actually. So you can reduce the fraction here. If you want to divide it, because we are going to be working with rate of change, you can divide it. So there we have it. Now, that's the slope of the graph. That's m, right? So m is our slope. So the slope is negative 3 over 25. And it asks us, can you interpret the slope as a rate of change? So interpreting means can you change this number and put some meaning behind it? What does it mean in the context of the question? What is the question asking for? That's what we want. So looking here, the gas in the tank and the distance traveled. Once again, we said the slope is rise over run, right? It's y over x. So what are the units? The units is L, and the units here is kilometers, km. So for us, the rate of change is negative 0.12, and the units would be liters per kilometer. Right? Y over X, rise over run. That's what we're looking at here. It's rise over run. So the rise, our Y unit was L, and that's why it's on top. And the X, the run unit, is kilometers. That's why it's on bottom. So the rate of change is negative 0.12 liters per kilometer. Once we have that down, okay, we're not just done yet. This is how much. So we're talking about gas remaining. This is how much gas, the car uses for 1 kilometer. Right? The car uses, I should say, how much liters of gas, to be more specific. Right? This is how much liters of gas the car uses for 1 kilometer. It uses up 0.12 liters per 1 kilometer. And so this is what you want to get used to. Finding the slope is the same as you've done before in the previous questions, but can you interpret it in terms of rate of change? Can you create a sentence for me that explains what this means in terms of the question? Okay. Are there any questions for this one? I'll zoom out so you can see the whole thing. Are there any questions here? Any questions at all?
I have a question.
Yes, what is your question?
So you're saying that m equals y2 minus y1 over x2 minus x1, is that always the same formula?
For the slope, yes.
There's never a different one.
Well, we have rise over run, which we can use if we have a graph with squares on it.
Uh-huh. But the formula is always the same.
Yes.
Okay, thanks.
All right. Anyone else? Okay. So we're going to move on then. So let's get some practice here. This is our last page of this sheet. Okay, so this is our last question for this sheet. So try this question here. It says here, Anson is training for the next Toronto Marathon in May. This morning, he ran 5 kilometers in 20 minutes. Part A is calculate the rate of change of his distance from his starting point. And B, graph the relation of distance versus time. C, calculate the slope. And D, interpret the meaning of the slope as a rate of change. Okay. So try giving this a shot. I'm gonna give you, or let's do the first part together at least. Let's do the first part together. Let's get you guys started here. So independent variable is the independent variable. Which one is it? What would you say the independent variable is? Which is the x-axis? The x variable.
Time in minutes.
Time in minutes, right? It's listed out right here, right? We have it on the x-axis down there. We know that time is going to be our independent variable. So time in minutes. And of course, we can also see, right, it says 5 kilometers in 20 minutes, and usually the second unit is our independent variable, which means our dependent variable is distance.
In kilometers.
Kilometers, very good. Now, the rate of change, what about that? What's the rate of change?
20 divided by 5. 20 kilometers divided by 5, so x divided by y.
Other way around. Not x divided by y.
Oh yeah, y divided by
Y divided by x. There you go. So not 20 divided by 5, but flip it. So it's 5 over 20. So what Mercel said is correct. It's going to be 5 kilometers divided by 20 minutes. And you can write the decimal. That's fine. If you reduce it to a fraction first, that would be 1 over 4 kilometers per minute. But then we usually change that to 0.25 kilometers per minute. Okay? So there we have it. So we divide it, we get 0.25 kilometers per minute. Now, let's see if you can finish off the rest. Could you graph the relation of distance, calculate the slope, and interpret the meaning? So I'll give you 5 minutes to do so, and then we'll take it up.
Seems as though the rate of change is always y over x.
Well, yes, it has to be because it's rise over run.
Rise over run is the rate of change all the time.
Mm-hmm.
Okay, thanks.
Okay, so let's take up what you got. If you didn't finish, that's okay. So the points you should have for sure, like if we were to kind of list out what the points that we have, and we said this is x and this is y, we know that the first point is going to be 0, 0. The second point would be easier to solve at 10, and the third point maybe we use as well is 20 and 5, right? Because we know that it's 5 kilometers in 20 minutes. Your graph should look something like this. So some kind of graph like that, and if we insert a line here, here to here, draw it as a black line, that would be the line for our graph. And so, as we do this, once again, making sure you know what points you're using, your graph should look something like this, and then you're done, right? So now then it asks us to calculate the slope of the line from the graph specifically. So the graph we are using, we are using our little grid here. So you can do a giant triangle here this way. That's terrible. Maybe I shouldn't use a highlighter. Maybe that's not a great idea. Let's change it. Let's use some more lines. Let's try to make it a little bigger. Okay, so if we use the lines here to kind of draw our shape, we'll use our orange line here to indicate like the triangle shape there. So if that's our triangle to calculate rise over run, we know that the run here, it goes from 0 to 20, so that's 20. And then the rise is from 0 to 5, which is 5. Oh, we get exactly what we want, right? We get m is rise over run using our triangle here with our grid. We know the rise is 5 and the run is 20. And we're going to get the exact same thing, aren't we? As we should expect, because we said that the slope is the rate of change. We should get the exact same thing back when you graph it. If you don't get it, something's wrong. So now we have our slope, and so can we interpret the meaning? Well, the rate of change was this. So what does this represent? If someone were to explain, oh, what does 0.25 kilometers per minute mean? Is what?
Is
It's
Earth
very
a speed?
simple. Yeah, it would be his speed. Perfect. It's very simple. Kilometers per minute, right, is Anson speed. Now, let's say you didn't know that it was speed and you wanted to explain. You can also write it like this. You could say Anson travels 0.25 kilometers in 1 minute, right? Both of these answers are correct. Doesn't matter how you write it, but as long as you're saying, hey, that's speed, I know that unit, that's speed, or you can specify that you understand that's how much he's traveling in 1 minute, right? 0.25 kilometers in 1 minute. So this is really important for you to understand as you try to figure out what it is going on here, right? What's going on here. So that's number one. And that's going to be the end of our review. Once again, there is a lot of extra work on Google Classroom that you can do. You should be trying those out during your free time, right? Please go and do the extra work because once again, you need to know how to do slope, you need to know direct and partial variation, all that kind of stuff for your test on Thursday. Let's keep going here. Is anyone still copying? Are we good? I think we're good. Okay. So we are now going to be working with 2.3. So if you haven't printed this already, please go ahead and print this. I'm going to give you 5 minutes to go on desmos.com. So as you can see, the link is there. Go to the website, www.desmos.com/calculator, and try graphing these relations. Okay. Try graphing them and then sketch them on this page once you have them. If you're curious as to how to type like x squared on Desmos, like, oh, I'm not sure how to do y equals x squared on Desmos, it's really easy. You would type it like this, right? And then if you use this symbol on Desmos, which is the shift 6 key, right? That's the symbol that will give you a power on Desmos. So please go and give these questions a shot. Try graphing them and then circle whether it's linear or nonlinear. We'll take it up in around 5 minutes just to make sure we're all on the same page on understanding what is linear and what is not linear. Okay, let's go through. Hopefully you've graphed some of it already. Okay. So y equals 3x plus 1. Like, it's a sketch. It's not going to be the prettiest thing. Like, sketching doesn't mean it has to be perfectly accurate, but it should look something like this, right? Going both ways. X squared should look something like this. I should hit the origin though. So it should look something like this. 1 over x looks a little weird, huh? Looks a little like this, right? X squared plus y squared equals 9 looks like a circle. That's my ugly circle. Don't judge me. Y equals negative 6x looks a lot like this. And x equals y squared. This is an interesting one, right? So it's weird because y is the one that's squared in comparison to x, right? So this is a slightly interesting one, but hopefully when you graphed it, you got the right answer. You should have gotten something that looks like this. Okay, so going through each one, let's take up each one here. First one, linear, nonlinear. It is definitely linear, straight line. Second one is nonlinear. Third one, nonlinear. Fourth one, nonlinear. Fifth one is definitely linear. And the last one is nonlinear, right? And so this is just kind of remembering, hey, linear means that it's a straight line. Nonlinear means it's not a straight line. Very simple definition. And we also remember that the relation is linear if the degree, which we talked about, the highest exponent inside the equation is 1. Right? Like when we look at the equation here, right? The x degree for both of these is 1. It's to the power of 1. Everything else is not to the power of 1. This one is technically to the power of 1, negative 1. And this one here is technically to the power of 1/2 because of a square root. So a lot of different changes here, but the main thing, once again, linear means straight, nonlinear means not straight. And also, you know it's linear when the highest exponent is 1. Anything else that's not 1, like whether it's negative or not, it's not linear. So let's take a look at each equation here. I'm going to call one person out at a time. So you either type it in chat or you can say it out loud, and it's okay to get it wrong. Okay? Because getting it wrong is still a learning situation. Okay? So let's look at this list here. Elia, your first question A, is it linear or nonlinear? Linear. Okay. B, Gerald, linear, nonlinear. B, you said linear. No, this is nonlinear. And the way you can tell is because the exponent is 2. The exponent is not 1, it's 2. So this is nonlinear. C, James, linear or nonlinear?
I can't see what the denominator is. It's too small.
It's 5 over x.
5 over x. Let's go wild guess. I'll go with linear.
This is nonlinear, not linear.
Dang it. I can't tell the difference.
Remember, guys, linear equations you already know have to be in this form.
Mx plus b.
This is linear. Anything that doesn't look like this is nonlinear. Y equals x, the next one, Kuzli, y equals x, linear or nonlinear? Linear. Very good. E, Mersel, linear, nonlinear?
Non-linear.
This is nonlinear? No, this is linear.
It doesn't say
This one
plus
is,
e though, it's minus.
but the exponent is 1. This is the slope. This is m, right? The
Are you
exponent
saying?
that comes
Can I say
after.
something?
Yes.
You're saying that any equation that has a constant is linear.
What do you mean by that? Because the constant is the number that comes after.
It comes after the operations. You're saying whatever number has an operation is linear.
Actually, no. If you look at question B, it doesn't. It has one too. It's nonlinear because the exponent is 2.
All right. Thanks for all that.
Row E, F, linear, nonlinear? Nonlinear. Very good. This is nonlinear. The highest exponent is 3 when it should be 1. And the last one here, Santiago. Linear, nonlinear? Santiago, you there? Five, 4, 3, 2, 1, 0. All right, Santiago, if you don't respond for the next one, I will have to put you as absent if you don't respond. I will, because I do need you to participate. Suyang, could you answer G, please? Linear or nonlinear? Nonlinear is correct. Very good. Okay, so this is nonlinear because, well, it's 4 to the power of x. That's definitely not in this form, right? It's not in y equals mx plus b. So we are going to get, of course, some more practice with understanding this, but please keep in mind how to check for linear, nonlinear, right? If you're given an equation, the main thing you're looking for, like if look at all the nonlinear ones, this is definitely not in y equals mx plus b form. This has an exponent of 3, not 1, right? So there are very easy ways to check whether it's linear or nonlinear. Okay. So now let's take a look at what we're learning new today, which is called first differences. So this is another way you can technically check for whether it's linear or nonlinear if you're given a table of values. So if I give you a table of values and I ask you, is this linear or nonlinear? Well, you're going to have to do some calculations for you to figure out whether it's linear or nonlinear. So here, let's fill out the table of values. So diagram number 1 has 1 cube, diagram number 2 has 3, diagram number 3 has 5, diagram number 4, well, it's growing by 2 cubes every time. So we can say that has 7, that has 9, that has 11, and that has 13. Because it's growing by 2 cubes every time, we're just going to add 2. Now, the first differences is a little bit interesting. The word difference in math, you should know by now, we've used it before, is subtraction, right? It's the answer to a subtraction. And the reason why we call it first differences is because we're subtracting for the first time, and we are subtracting the y values. So what you'll notice that we are actually subtracting the 3 first before we subtract the 1. It's quite interesting, right? We're subtracting the 3 before the 1. And so because we're subtracting the 3 before the 1, our answer is going to be 2. I don't know why it's doing this. Okay. And you'll notice we keep doing that. So it goes down as a pair of numbers every time like this. And you're always going to go bottom number first, then the top number. Okay, so it's like, for example, the first one is 3 minus 1. The next one is 5 minus 3, right, which would be 2. The next one would be 7 minus 5, which is also 2. And then the one after that would be 9 minus 7, which is 2. 11 minus 9, which is 2. And then 13 minus 11, which is 2. Okay, so the first difference is a little weird because we're used to going top down, like, oh, why is it not 1 minus 3? And it's because the second number is the point that comes after. So we actually have to use that one first. It's a little bit confusing, but I will give you a little bit of a, I guess, advice or a tip to make sure we don't get it wrong. So first, let's look at what we've done here. We've subtracted the pairs of y values. Notice how we're not subtracting the x values at all, right? Just the y's. And we'll notice that all of the first differences are the same. They are the same. So all of the first differences are the same. The second thing I want you to notice is the x values, the diagram numbers here. What's really, really important about these diagram numbers is understanding, right, that with these diagram numbers, they're evenly spaced out. So in other words, they're going up by 1. They should always go up by the same value. So it's either all going up by 1, or all going up by 2, or all going up by 3. It can't be like, oh, it goes up by 1 here, it goes up by 2 there. We want it to be consistent for the x values. That's the goal. Okay. So let's graph the relationship. Is it linear or nonlinear? So if we were to graph the total number of cubes and the diagram number here, let's zoom out a little bit. So diagram number is x. So we're going to put that I'm going to put that diagram number here, and we'll call that n. On this side, it's total number of cubes, which is t. And we're going to label it. So diagram number goes 1, 2, 3, 4, 5, 6, 7, 8. And on our graphing here, we don't want to copy this down. If you copy this down here, you're wrong. 100% wrong. And the reason for that is because, look, 1 square is 1, and then you go up to 3. Doesn't really make sense, does it? Right? Once again, the scale has to be consistent. This is where one of the biggest mistakes happen. Everyone thinks, oh, I can just copy down the y values. It's evenly spaced out. But 0 to 1 is not even to what you were currently doing. So instead, I would actually go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16. And that allows us to graph it. The first one is 1, 1, which would make it halfway down. And then 2, 3, 3, 5, 4, 7, 5, 9, 6, 11, 7, 13. And if we were to do 8, it would be 8, 15. And so there's our graph there. Santiago, you there? Type something in the chat if you are there. Could you tell me, is this linear or nonlinear? Right? Does it look like a straight line or does it not look like a straight line? Linear, very good. It's definitely a straight line, right? Perfectly straight line. It doesn't look like a curve. Everything's lined up perfectly. Great. It's a linear line. So What can we say about first differences then? Well, they were the same. Oh, the graph is linear. So we can kind of assume that there must be something connected with each other, right? With linear and straight line stuff. Oh, and first differences. I said linear and straight line stuff. Linear and first differences. So there is a connection there, and we'll talk about that now. Okay? Is anyone not done copying this down before we move on here? Okay. So first differences here, right? So the first differences are the differences between consecutive, one after another, y values in a table of values with evenly spaced out x values, right? We always have to make sure the x values are evenly spaced out. So to check our first differences, we check that the values of x change by a constant amount, number one. And number two, we subtract the y values working from bottom to top. This will make sure that you don't mess up. So, for example, we'll go through some of his here. But when you notice that the first differences are constant, it is linear. If the first differences are not constant, it's nonlinear. So whenever you're given a table of values and I ask you, is this linear or nonlinear? I'm asking you to do the first differences and can you check if it's linear or nonlinear? Are the first differences the same or are they different? That's what I'm asking for. So looking here at our first example, let's classify them whether these are linear or nonlinear. So this is the first differences here, right? And so how you're going to do it is from bottom up. First step, we check the x values. Oh, are they constantly going up by the same value? And we can say, yes, it is. 0, 2, 4, 6, 8, 10. All the x values are going up by 2. We're okay. We're good to go. So now we can calculate the first differences. Looking at the first differences here, we go from bottom up. So these two going up, we take the bottom number first and subtract the top number. So this would be 27 minus 17. Okay? Bottom up, we're going this way on the y values here.
Answer is 10.
Answer is 10. So we're going to put in 10 there. The next one is 17 minus 9, right? Bottom up, next two. 17 minus 9.
8.
8. 9 minus 3. 6. 3 minus negative 1. So let me write down the values here.
The answer is 4.
Good. This is 4. So 3 minus negative 1. And the last one here is negative 1 minus negative 3. It would be 2. So is this linear or nonlinear?
Can I get a hint for linear things?
James is saying it's linear. Does anyone want to confirm that or agree or disagree?
Just give me a hint for linear things.
Your hints are all on the top.
Okay. Right.
Anyone else? Is this linear or nonlinear? Do I have to make a poll to make sure that everyone's actually paying attention here? Come on, guys. Linear or nonlinear? Someone give me. And Elia saying linear. No, this is not linear. This is non-linear, guys. What does it say here? If the first differences are constants, it's linear. Are these values constant? No, they're changing. The first differences are always changing. It's 2, 4, 6, 8, 10, right? That's different. Those are different values. So this is not linear, right?
It's not. It's so different. Right? So different.
So let's do the next one here. First step, we check, are the x values the same or going up by the same value? Yes. -4 to -1 is up by 3. -1 to 2 is up by 3. 2 to 5 is 3. 5 to 8 is 3. 8 to 11 is 3. So we're good there. Then we work upwards, right? So the first thing we're going to do here is 15 minus 10. That's our first one. 15 minus 10, that's going to be 5. Next one, next two, 10 minus 5 is going to be 5. 5 minus 0, 5. 0 minus -5, 5. And -5 minus -10, 5. Linear or nonlinear? Linear. Good.
Linear.
Everyone's being linear. Good. Now it's obvious, right? Now we're looking at it, what we should be finding if it's linear. Everyone's like, boom, boom, boom. Got much faster responses this time, which is good, right? So now you understand, oh, if it's different, it's nonlinear. If it's the same, it's linear. Will you be able to calculate this on your own, right? Because I'm not always going to give you these boxes, right? Sometimes I just give you just a straight table of values. You need to be able to calculate it yourself. So this is first. Okay. So here it says for each, this is practice.
I get it now.
So
Okay. So this is practice I want you to do. For each equation, create a first difference table for x values from 0 to 4 and classify each relation as linear or nonlinear. So I'll do the first one as an example, right? So if we create a table of values here, let's zoom in. Working with something like this, x and y, we want 0, 1, 2, 3, and 4. And what we're going to do in the y section, if you want, you can kind of write it like this. And I know some people like doing this to show their work. Like, for example, they say, oh, this is -3 times 0. I replace my x with 0, and then I can say my answer is 0, right? Or if you don't like doing that and you want to keep it plain and simple, you plug it into the equation and you can just write your answer. Whichever way you want, I'm okay with that. So I'm just going to write down and show my work here so that no one gets confused. So y is equal to -3 times 0, y is equal to -3 times 1, y is equal to -3 times 2, y is equal to -3 times 3, and y is equal to -3 times 4. Plugging it in, we get -3 times 0 is 0, -3 times 1 is -3, -3 times 2 is -6, -3 times 3 is -9, and -3 times 4 is -12. So there are our answers. And then we need to do our first differences. Now you'll notice, oh, Mr. Choi, we have to draw it ourselves. I don't know. I can't really draw first differences very well. That's okay. There's a way you can do it, which is to use this. Starting from bottom to top, you draw your kind of like a sideways V connecting these two, and then you can write out -12 minus -9, and you do that math, you get -3. Then the next two like this, -9 minus -6 is equal to -3. -6 minus -3, and then negative 3 minus 0 is negative 3. Is this linear or nonlinear? First difference.
That is totally linear.
Very good. This is definitely linear. All the first differences,
Totally.
all the first differences are the same.
If every number is the same, it's linear. That's pretty simple to know.
Very good. So all the first differences are the same.
I see why education is so important.
So first differences, they're all the same. It's linear. Boom. So you have 3 more questions to go. Please try the next 3 questions on your own right now. Once you are done, please DM me on Google Meets. Make sure you can check off. So if you look here, you can click here, and then you can message me. My name should pop up, and then you can private message me. I will check your answer for each one, and then we can go from there. So that is going to be it. Please try it yourself, and so send it to me, try it yourself, and then I'll let you know when you can go. Otherwise, make sure you know you have homework. They're all on Google